Okay, so today starts our new unit called quadratic equations and solving them. We talked about factoring them last unit. This unit we're going to solve, we're going to talk about the characteristics, kind of how we did when we were talking about linear functions and exponential functions. So past units we talked about linear, which was just a straight line, y equals mx plus b, ax plus by equals c was another way you could have wrote it. You learned about exponential functions, which was a curvy line going up exponentially. Your equation was y equals a b to the x, or y equals a 1 plus or minus r to the x or t, depending on time. Today, in this unit, we are talking about quadratics. The graph of a quadratic function is called a parabola. It looks like this, or like this. It'll never turn any other way. It'll either go up or go straight down. There are 3 forms of quadratics, so just like on the back page when I named a couple different forms of linear functions, exponential functions, there's 3 different forms of quadratics. The first one is the one you're most familiar with. If I cover up the f of x, that's how we graphed quadratic or factored quadratic trinomials. This is called standard form. And remember, you can replace the f of x with a y instead. This next one with the h and k, this should look familiar to you. This is vertex form. And the last one is factored form. So when you take the standard form and factor it, it would end up looking like that. But we're going to use standard and vertex the most. You're going to see a couple examples of factored, but you'll be fine. It'll make a lot of sense. First thing you need to know, when your a in standard form is greater than 1, it has a minimum, and we'll talk about that later. The graph looks like this. So when your a is positive, your u is upwards, meaning your vertex's very, very bottom point is a minimum. It's your minimum value. When a is less than 1, it's going to have a maximum. So when a is negative, your parabola is flipped, and your vertex is your highest point. Okay, a couple more vocabulary we need to go over. Your y-intercept, you know this from linear equations and exponential functions, is the same thing. It's where it crosses the y-axis. When it's in standard form, it's your c value. So if we look over here, here's where it crosses your y-axis. You are going to write y-intercept, kind of so you have a reference when you're trying to figure out which is which. The next one is your axis of symmetry. It's where you could fold a line that divides a parabola into 2 halves. So it's always a line, so that's why it's going to say x equals. It's always an up and down line, and that's why it's x equals. So we talked about that before too. This line that cuts straight down the middle, goes through your vertex, is known as your axis of symmetry. This one in particular, since it's cutting through your 1 here, would be x equals 1. That's how you would write your axis of symmetry. Your vertex is your highest or lowest point. It is your turning point. So what that means is from here to here on your parabola it's going down, 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 and then it hits the vertex and it changes directions and goes straight up. Your vertex here is a minimum. Oops, brought it up. And that's your vertex. Your max or your min value is the y value of your vertex. So if I look here at what my value of my vertex would be, it's 1, -4. So if they wanted the minimum value, your minimum value would be -4 because it's your y value of your vertex. And it'll make more sense when we start doing word problems with parabolas. Your x-intercepts or your roots can also be called solutions. And we talked a lot about roots when we were factoring. It's where your u crosses the x-axis. They are your x-intercepts. So we have one right here, and we have one right here. Those are your x-intercepts. You need to make note that you can either have 2 x-intercepts, 1 x-intercept, or no x-intercepts. And we're going to go over a ton of examples so you can see what that means. Your domain is your set of all possible x values. So we've talked about this in detail too. See how the arrows are going up? It means it's never ending and it's going to continue as far as it can left and right. So your domain for all parabolas is all real numbers. We also write it with the infinity symbol, with parentheses like that. It's up to you, but domain will always be all real numbers because it's always going in both directions outwards for your x. Your range is a set of all possible y values. So we have to relate and use our vertex for this one. So the lowest it goes is -4, and it's included, so it's a bracket, and it's going to shoot up. The arrows just keep going up, 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 to positive infinity, which would be a parentheses. You could also write it as y is just greater than or equal to 4. You're going to see a lot more examples use this method, which is fine, just get used to it. Your decreasing interval is the downward slope to or from the vertex. So when it's flipped the other directions, that's why it says to or from. Decreasing interval is the part of the u that has a negative slope or is going downwards. So here we are going down, so that's our decreasing interval. So we're going to use our x value of our vertex, which is 1, and x is less than 1 for all our values that are decreasing. Then we're going to use 1 again for our increasing interval, which means it goes up. And instead here, x is going to be greater than 1, going upwards. All right, let's try a few examples on the next couple pages together, and hopefully it'll make a little more sense to you. Okay, so here's our first example. They want the y-intercept first. Our y-intercept is this point right here, which is -3, so 0, -3. We want our axis of symmetry. That's the line that's going to cut it in half. So I'm going to draw a straight line up through my vertex. It crossed through 1. So my answer is x equals 1. You cannot just give me 1. You need to say x equals 1 because it is a line. You don't tell me that, you're wrong. You need x equals 1. Your vertex here is all the way down here. That point is 1, -4. Your roots are where it crosses the x-axis. We have one here, which is 0. You have 3, 0. And we have one right here, which is -1, 0. Those are our two x-intercepts. Is our vertex a maximum or minimum? Since it's the lowest point on the graph, it's a minimum. So then it's a min value. The min value is always your y in your vertex. Your min value is -4. Domain, all real numbers. Always. Your range, we're using the lowest point or the highest. Here it's our lowest, -4. So y is greater than or equal to -4 because it's going upwards. So all these values here are greater than -4. Your decreasing interval is your downward part. So we're going from -infinity straight down to our vertex value of 1. So x is going to be less than 1 because it's all these numbers that are less than 1 over here. And then my other side is x is greater than 1. So at 1, that turning point, my sign flips and it's going to start getting bigger and my x values are positive. All right, let's look at another one. Start with y-intercept. Our y-intercept here is 5. so 0, 5. Our axis of symmetry is the cutting point straight through the middle. It crosses -2, so our x equals -2. That's our line, our axis of symmetry. Our vertex here, it's hard to see, is -2, 1. Our roots is, remember, where it crosses the x-axis. This parabola doesn't cross the x-axis at all, so there actually is no x-intercepts. And remember, we talked about on the front page, sometimes there isn't any, which is okay. Is it a max or a min value? It's a minimum. It's still the lowest point. Our min value would be 1. Our domain, again, is all real numbers. So our x value is all real numbers. Our range includes the lowest y or the highest y. Here it's our lowest, which is 1. So y is greater than 1. Since all our points are greater than 1, it's going upwards. Decreasing interval is still going down this side of the parabola. So x and our x value is -2. So because all these points this direction are less than -2, I use the less than symbol. I still have x and -2, and because on this side it was all less than -2, since that's our turning point, x is going to be greater than -2 for our increasing interval, so the parts that are going upwards. Let's flip. We just have 2 examples left, so we're just going to go through them. If you notice, our parabola flipped directions for this. It went from going upwards to now flipping downwards. Our y-intercept, here's 3. Our axis of symmetry is this line that cuts through. I think I cut through wrong. It should be at -1, so x equals -1. Sorry. Our vertex is this point right here, which is -1, 4. And also, if you've noticed or you've caught on, our vertex and our axis of symmetry have the same x. It'll always occur like that. Our roots here are our x-intercepts, so -3, 0, and 1, 0. Now, is our vertex a maximum or a minimum here? It's our highest point, so it's a maximum. Making it a max value, we're still using our y, which is 4. Your domain never changes, it's all real numbers. This time it's just going downwards, but still it's going down forever and ever and ever, and you're not going to know when it's going to stop hitting all your x's. Your range is still y. We're still using 4, but instead here, all these numbers going downwards are less than 4, so less than or equal to 4. Your decreasing interval is a little different now. Your decreasing interval is on this side. We're still using our x. We're still using our vertex at -1. Now think about it. All these numbers going to the right of -1 for our x's, are they greater than or less than -1? We have 0, 1, 2, 3, all these. They're greater than -1. The other side then would be x less than -1. And let's look. Aren't all these points less than -1? -2, -3, -4, -5, -6, all the way down for our x's. So that is why it's less than -1. I noticed on this one I switched the sign. It should be greater than or equal to. So make sure you just go back to fix that. Okay, very last example. Our y-intercept, it's actually crossing at the origin, which is 0, 0. Axis of symmetry then is just x equals 0. Our vertex here is a little weird. It's also 0, 0, because that's our highest point. Our roots, it's only hitting that x-axis once at 0, 0. So you only have one root there. Is it a max or a min? That is your highest point, so it's a maximum. Making your max value the y, which is 0. Domain still is all real numbers. Your range, y, and we use our 0 from our vertex. Are all these numbers greater than or less than 0? They are less than or equal to 0. Since the parabola is flipped, my decreasing interval is this direction. You can tell the slope's going downwards. So we're using x, and we're still using 0 because that's our x value of our vertex. We know that all these values this direction are greater than 0. And our increasing interval then is all values less than 0. Alright, make sure you took these notes. If you have any questions, just come see me. You will have another assignment to finish. Okay.